question 6 is dealing with the use of the bond enthalpies to determine the enthalpy of the reaction. So usually what I recommend is for you to draw the Lewis structures. So if you look at CH4, that's carbon connected to 4 hydrogens, and then oxygen double bond, there are 2, and then for our products, what we have? For our products, we have carbon dioxide. Okay, so carbon dioxide, I think that's like double bond to like this, and then we've got 2 water molecules. Water has got oxygen bonded to 2 hydrogen atoms, and then these are 2, so I'll put a subscript of a coefficient of a 2, just like we did on the oxygen part. So now we can identify how many of these we have. So if we try to observe on the reactants here, how many carbon to hydrogen bonds do we have? We can see there are 4, right? So 4 carbon to hydrogen bonds. For this one, we've got, there's a single double bond of oxygen. Now, because of a 2 there, it becomes 2 because of that coefficient. For carbon dioxide, we have 2 of carbon 2 double bonded to oxygen. And then for water, water itself has a single molecule. It has got 2 oxygen to hydrogen bonds. Then we also have a coefficient of a 2 there. Okay. Now, what's the formula? The formula is, for the bond enthalpies, you focus on the reactants minus the products. For the formation, it's products minus reactants. So usually you just say what is broken. Bonds are broken for the reactants for a reaction to proceed. So we need to determine the amount of energy that was required to break, and also now to have as formation of the products. So just substitute. So where we're just having this sign, it's kind of like we're just going to have a negative or a subtraction. Our reactants minus the products. Now we substitute. We have been told carbon to hydrogen is 412. So 4 times 412 plus the 2 times the oxygen double bond is 496. All these are kilojoules per mole, right? So let's actually use different kinds of brackets there. And then minus, so we've got 2 carbon to double bonded to oxygen, that's 803 of energy, plus 2 times 2 will give us a 4 for oxygen to hydrogen, which is 463. Okay, so we can just subtract the 2. So 4 times 4, 12, that's giving me 1648. 2 times that is giving me 992. So if we add the 2, I'm getting 2640 minus this part. What are you getting? That's giving me 3458. And if you subtract the 2, 2640 minus 3458, that's negative 818 kilojoules. So this is the enthalpy for the reaction, okay, using the bond enthalpies. Equally here, there's a video where I've introduced this in more detail, okay, so you can actually learn more about the bond enthalpy calculations with several practice questions. Check out the topic thermochemistry just right on our site, link in the description below. So that's it to this video. Thank you very much for watching.